Hi guys, a very good morning everyone. Welcome to the class, welcome to the session, and welcome to the special practice sessions on one of the very important topic, that is the eigenvalues and eigenvectors. Okay, we shall be discussing the eigenvalue and eigenvectors in the today's session, right? Okay, different variety of questions, and through which of course all your miscellaneous properties, miscellaneous important points and application of eigenvalue and eigenvector would be covered. Okay, so yeah, let everybody join quickly. Very good morning everyone. Keep joining the class, and yes. Okay, so then if it's all good, let's get going ahead. Okay, let me know if there is by chance any issue with audio and video. Okay जी, done है. चलिए जी, so let's get started in that case. Important questions from eigenvalues and eigenvectors. Okay, the 2 months left for the upcoming GATE examination, so important areas must always be focused with good variety of question practice. Very good morning Sai Krishna, Rajesh, Hari. Okay, so this is a regular introduction about me. Let's get moving ahead. So guys, the big time update, as you all know, is UPSC Engineering Services results were announced some time back, and BYJU'S exam prep users have really outshined. Okay, with All India rank 1, All India rank 9. Okay, 5 students under rank 10, 29 under rank 50, and 37 under rank 100. Okay, so guys, starting with the first question. Okay, so starting with direct question and then property based question. Okay, what I can only assure you is ki yes, if you are following the today's class, if you are following the today's class, okay, you can say that each and every variety of questions that can come up from eigenvalue. I don't say exact this question can come because GATE mein questions don't repeat, you can't predict, but exact each and every variety of questions from the different areas, whatever is expected from eigenvalues, okay, that can really be focused through this section. That's what I would be trying here. Okay, so first question, starting with the basic 2 cross 2 matrix. Okay, determine the eigenvalues of the matrix. Okay, so first question. Yeah, audio is fine. Determine the eigenvalues of the matrix. Okay, so that is 1, 2, minus 1 and 4. It's a 2 cross 2 matrix. So normally when we want to talk about eigenvalues, okay, we will be solving it as the root of characteristic equation. We'll be solving it as the root of characteristic equation. In general, we know that the characteristic equation modulus of a minus lambda I equal to 0. Okay, and do you need to start solving this for every matrix? No. If there is a direct question, most likely 2 cross 2 or 3 cross 3 matrix, isn't it? Okay, so I will give you the direct characteristic equation format for 2 cross 2 matrix. Okay, so if there is a 2 cross 2 matrix, dear, very important, you should directly remember this characteristic equation, used in many questions, used in Cayley-Hamilton theorem as well. Okay, so answers have started coming up. Correct, Rajesh, that's what it is. So you know what is the characteristic equation? Lambda square minus trace into lambda, okay, plus determinant, okay, plus determinant of the matrix equal to 0. Now, what is trace? Sum of diagonal elements. Okay, so specifically for this matrix, it is gonna be lambda square minus trace. Trace is 1 plus 4, that is going to be 5. Okay, and plus the determinant is just 2 cross 2 cross multiply 4 minus 2. Okay, and hence you have lambda square minus 5 lambda plus 6 equal to 0. Factorize kar dijiye, ya solve by the quadratic formula. Simple answer that is going to come is the lambda is equal to 2 and 3. The lambda would be equal to 2 and 3. That's what it is. Okay, so always remember this characteristic equation for 2 cross 2. Okay, directly you can also solve by trace and determinant, but I suggest you to remember, because you know the same thing can be directly applied in theorems when Cayley-Hamilton theorems will come into the picture. Okay, so correct answer Setupati, Ankit, Ananta, Hari. Okay, chalo. So next question now. So if it is 3 cross 3 by chance, okay, if it is 3 cross 3, okay, we know that the general characteristic equation nature remains to be same, na? Modulus of a minus lambda equal to 0. But what is that specifically for 3 cross 3? Rather than first writing a minus lambda I and then determinant equal to 0, what is that I can do directly? Uski baat karte hain. Okay, so if there is a 3 cross 3 matrix as here in this question, okay, what is the characteristic equation? You can remember it in the format lambda cube minus beta 1 lambda square plus the beta 2 lambda minus the beta 3 equal to the 0. Lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. Then what is this beta 1, beta 2, beta 3? Okay, so beta 1, okay, is known as the first coefficient that is coming up is the trace. Beta 1 will be the trace only. Okay, that will be the trace only. What is going to be the beta 2? Beta 2 is known as, now trace is what? Trace is sum of diagonal elements, we know. So what is beta 2? Remember it like sum of the minors of every diagonal element. Sum of the minors of the diagonal element. For every diagonal element, calculate the minor and add it up. Just remember this definition, no need for the formula. You know how to calculate minor. And the last constant term that always corresponds to the determinant. So the beta 3 will be determinant of the given matrix. Okay? Okay. Good morning, Bhanu. So just we have to apply this and we can put this into the cubic equation. Let's get going ahead. Achha, there is one clear observation here in front of me. Let me write down the matrix actually so that we start calculating. So we have 1, 4, 6, 2, 8, 3 and then we have 1, 4 and minus 3. Okay, I have a very clear observation by looking into the arrangement of the numbers. So when I subtract this, have a look into this. 2 minus 1 is 1. 8 minus 4 becomes 4. 3 minus 6 becomes minus 3. So when I subtract these numbers, okay, subtract what? Subtract the second row and first row. So when I subtract R2 minus R1, I am able to get R3. That means the rows are dependent. Okay, and whenever the matrix has dependent rows, similar rows, proportional rows, anything, any dependency in the rows, the determinant of the matrix is eventually 0. So that calculation is directly 0, you can say. That calculation is directly 0. Okay, now next let us come to the other parameters, like what is the beta 1? Beta 1, as I told you, simply the trace. Sum of the diagonal elements, and that's gonna become 6. Okay, what about the beta 2? Beta 2 is, just remember that line, sum of the minors of every diagonal element. Okay, so like this is my first diagonal element, and how do I calculate its minor? I delete the row and column. I get the remaining 2 cross 2 whose determinant to be calculated. Okay, so that is gonna be how much? Let us write down here 8 into minus 3, minus 24, minus 4 3s are 12. Then next minor, so second diagonal element, delete the second row, second column, and then solve this determinant. Second 2 cross 2 determinant, just cross multiply. So minus 3, minus 6. Minus 3, minus 6. And the third minor is going to be, this is the third row, third column. This is 8, minus 8, and this is going to turn up to be 0. Okay. So what is eventually beta 2? Minus of 36, minus of 9 and 0, that is minus of the 45. And then let's talk about the beta 3. As I mentioned, that is trace and that is determinant, and that is eventually calculated as 0. So what is going to be my characteristic equation here? It is given by lambda cube minus beta 1 lambda square. Okay, beta 1 is trace, that is 6. Okay, plus beta 2 lambda. Beta 2 is negative 45 minus beta 3, and beta 3 is 0. Okay, so you have lambda cube minus 6 lambda square minus 45 lambda equal to 0. Let me keep reminding you that in GATE you have the virtual calculators now. Okay, you know that scientific calculators are not there in the GATE. The regular, the physical scientific calculators are not there. You have the Casio, the online virtual calculator, and in that virtual calculator there is not the equation. The equations is not incorporated. You can't solve cubic and quadratic equations there. So for quadratic you have the formula. For cubic, you don't have formula. So in case if a question is coming in cubic, don't worry, they know that the IISc, when they're going to set the paper, set the final question paper, they know cubic equation ke liye formula bhi nahi hai, and you don't have it in the calculator, so they will be setting the data accordingly. Like here, ultimately, it is 0, the beta 3 is 0, so ultimately lambda can be common, and then if you take lambda common, you are left with the quadratic part, or they may be giving you a cubic equation which can be factorized, which can be easily factorized. So they'll take care of that facts. Okay, don't worry about that. Okay, so I have maybe lambda equal to 0, and then 6 plus minus root over of, it's like minus b plus minus root over of b square minus 4ac, so 4 into 45, 180, minus minus plus. Okay, and then divided by 2a, so lambda is going to be 0. Okay, 6 plus minus, this is 216, that is 6 cube. So 6 cube, square is outside the under root. Okay, so only 6 is left. So 6 root 6 by 2, cancelling by 2. So the final eigenvalues are 0. Okay, 3 plus minus 3 root 6. So I can say 3 plus 3 root 6, 3 minus 3 root 6. Irrational conjugate pair is there. These are the eigenvalues. Okay. Now guys, you will see that, okay, you will see that it's not only direct question, but there will be many property based questions. So we look into, I told you, we look into every aspect today. We are going to look into every aspect today. Okay. Okay, Sai Krishna, don't worry. I will take a separate session only on vector space. Okay. ISC here, I think question also can be expected. So I will take a separate section on, vector space and basis. Okay. ठीक है, Rajiv Kumar, just noting down all this. ठीक है, Shamshuddin, we'll plan for that also. ठीक है, चलिए आ जाते हैं. So now, okay, let's move ahead to the next question. Let's move ahead to the next question. Now, if the eigenvalues of a matrix are given to you, what is the value of alpha and beta? So, alpha is a parameter which is hidden inside the matrix and beta is one of the eigenvalue. Okay. Now, especially when it comes to, MCQ, when you have choices. Okay, when you have choices. Okay, then what is going to happen? Okay, you can just use the properties as you are able to see here also. If you add these eigenvalues, if you add all of them, 3 root 6 minus 3 root 6 cancel, it is 3 plus 3, 6. Okay, and 6 is also the trace. Also, if you multiply them, multiplying will give you result 0. The determinant is also 0. Okay, two most used properties of eigenvalue. Properties बहुत सारी होंगी, but two most used properties of eigenvalue, have a look into it. Very, very important. Sum of eigenvalues is always equal to trace of the matrix. Okay. Sum of eigenvalues is trace. Product of eigenvalue is always determinant of the matrix. One more, let me add on. Okay, a matrix and its transpose will have the same eigenvalue. A matrix and its transpose will have the same eigenvalue. There's some key points we'll keep noting. Okay, property ko, I'm not writing down all the list of, there will be, say around 15, 16 properties. I'm not writing down one by one so that you remember. No, let us apply on every question. Okay, so today's session, as I told you, it's an important question, but with every important question, you will learn eventually one by one all properties. That's what, I can assure you. So, chaliye aa jate. These are the most simple properties. Yeah, eigenvector different hoga Ananta. When I come to eigenvector, I will put down that point also. They have the same eigenvalues only, I'm telling you. Eigenvector will be different. I'll place down that point also. चलिए अभी आ जाते हैं इस क्वेश्चन पे. So I can just use this properties. Okay, MCQ question is just try to use the properties. Okay, so what I told you, try this. Sum of lambdas should be equal to the trace of the matrix. Correct. So what is the sum of the lambdas? Sum of eigenvalues is 4 plus minus 1 plus beta, and that is going to be trace. That is 2 plus alpha plus 3. Okay, so that is now 3 plus beta is equal to 5 plus alpha. Is equal to the 5 plus alpha, right? Or I have beta minus alpha, one relation is 2. Can I satisfy the option? Beta minus alpha, alpha beta hai, to beta minus alpha, beta minus alpha. I think only one option is matching up. There are two variables, you need two equations. Second one kaise aayega? Second one will be through the determinant. Second one will be through the determinant. Okay, but not required, na? Not required. Beta minus alpha equal to 2 in only option number C. Okay, it is only in the option number C. Correct, everybody? Yes, Sai Krishna. Okay. So, yes. Honestly, Bhanu, I don't remember the number of questions today. I have not counted also. But yeah, I have taken questions so that all properties are covered. So, exact number, honestly, I don't remember. Next question ki taraf chalte hain. Okay, have a look into it. Okay, now, look into it. Look into it. अच्छा यहाँ पे ना there will be one more property to be used. Just hold on. Okay, just hold this question. I'll tell you one more property before we talk about this. या चलो बता ही देता हूँ. In the flow, let us talk about this property also. Okay, so guys, first let's start attempting this question and I'll come to the property. A 2 cross 2 matrix A has the eigenvalue. A 2 cross 2 matrix A has the eigenvalue e power I pi by 5, e power I pi by 6. This is a good question. This is a good question. What is the smallest value of n such that A power n is equal to identity? Such that A power n is equal to identity. Now, matrix is not given to you, but the eigenvalues are given to you. Matrix A is 2 cross 2, but that is not given to you. Okay. Now, you are required to find the smallest number n such that matrix A power n should be equal to the identity matrix. Acha, if these two are equal, let's talk about the determinant. Modulus of A power n should be equal to modulus of I, and what is the determinant of identity matrix? Identity matrix, be it of any order, 2 cross 2, 3 cross 3, 10 cross 10. Identity matrix has determinant 1. So eventually I can say that modulus of a power n will be equal to 1 and determinant of a matrix is product of eigenvalues. But you are given the eigenvalues of A. Dear, you are given the eigenvalues of A. A has the eigenvalue e power I pi by 5, e power I pi by 6. Okay. It has the eigenvalues e power I pi by 5, e power I pi by 6. Okay. Then what about a power n? Acha, let me ask you, let's mix some properties here. Just let me ask you one question. Can the matrix A be a real matrix? Just out of this question, forget this, okay. Can the matrix here be a real matrix? Can the matrix here be a real matrix? Tell me. What is your opinion? Matrix is not given, just asking you, okay. Can the matrix here be a real matrix? Any guess, yes or no? Yes or no? Take a guess, no problem if you're not able to relate. Right. Yeah, definitely it's not. Why not? Why not? वो ध्यान रखना जरूरी है. Because if one of the eigenvalue is e power I pi by 5, that is a complex number. And if you have a real matrix, complex eigenvalue always occur in the conjugate pair. If matrix A is real, with e power I pi by 5, its conjugate e power minus I pi by 5 will always be there. 110% sure. If the matrix is real. But if the matrix is non-real, say complex, okay, then this conjugate property not necessarily true. So let me introduce two properties here. Okay, let me introduce two properties here. No, Rahul, यहाँ पे skew symmetric नहीं होगा. So let me introduce two properties here, then we come back and finish the question. Okay, so yeah. Let me jump to that first of all. Yeah, here. This is what I just told you. If there is a real matrix, okay, then alpha plus minus I beta complex conjugate pair will always be there. I mean, if there is a complex eigenvalue, I'm not telling that complex eigenvalue will be there, but if there is a complex eigenvalue alpha plus I beta, then alpha minus I beta उसके साथ होगा. Complex eigenvalue occur in conjugate pair, but if the matrix is real, above property does not hold. Okay, for a complex matrix. What is a real matrix? All elements should be real. What is a complex matrix? Even if a single element is complex number, okay, that will be a complex matrix. Okay, that is one point. Now, next point to learn for this question is, I'm just mixing some properties here. Okay, but no problem. Have a look into it. Important hai. This one, very important properties. These are like important properties. Okay, so you are given the matrix A whose eigenvalue is lambda and suppose the eigenvector is x. We'll come to eigenvector questions also very soon. Okay, you are given a matrix A whose eigenvalue is lambda and eigenvector is equal to the x. Clear? Then, if there is a matrix A power n, the eigenvalue will be lambda ki power n with the same eigenvector. Okay, if there is the matrix A plus I, you add identity in the matrix. So in the number unity, it's like unity matrix, so unity number 1 will be added, same eigenvector. Okay, if you have k into A, if you multiply A by any scalar number k, the eigenvalue also becomes k into lambda, eigenvector remains to be same. So basically, whatever operation you apply on the matrix, same is applied to the eigenvalue. Okay, यहाँ पे questions discuss करेंगे. Same is applied to the eigenvalue. ठीक है? Same is applied to the eigenvalue. So with respect to this, let me also add on. Okay, what are the eigenvalues of A inverse then? What are the eigenvalues of A inverse? Okay, n equal to minus 1 can be there, na? N equal to minus 1 can be there. Okay, so then the eigenvalue will become lambda inverse, that is 1 by lambda. Right, so whatever be the eigenvalues, all will be reciprocated. Eigenvalues will be 1 by lambda. Eigenvector remains to be same. Okay, if there is the matrix A transpose, as I already mentioned, eigenvalue remains to be same. A and A transpose have the same eigenvalue. Okay, but in case of transpose, okay, the eigenvector would be different. What it is, we need to find out. Okay, depending on the matrix. I can't give you any answer here. Okay, but I can tell you that it will not be x. I'm not writing it as x. It can be something else that depends on the given matrix. Uske basis पे ही निकाल सकते हैं. Clear? But yeah, the eigenvalues will be same. For A transpose, eigenvector will not be same. Achha. There is a doubt coming up. What about the eigenvalues of adjoint A? Chalo, let us discuss that. What about the eigenvalues of adjoint A? We'll discuss that. First, let's complete that question. I'll explain you how to calculate the eigenvalue of adjoint A. We'll come back to it. Okay? We'll come back to it. Okay, so we'll come back to it. Just wait. Let's go back to the question. Okay, so we were on to a question. Yeah. Let me go back there. Yeah. Okay. So as I told you, there is a matrix A whose eigenvalue is given e power I pi by 5 and e power I pi by 6. Okay. So for what is the eigenvalue of a power n? The eigenvalue for a power n will become lambda power n. Okay, will become lambda power n. That is the eigenvalues will be, take the power n. So e power I n pi by 5, e raised to the power I n pi by 6. Okay. Now the question is, okay, what is the smallest n such that a power n equal to I? So I took mod of a power n, mod I is 1. Determinant of identity matrix is 1. So mod of a power n should be 1, and determinant of a matrix is product of lambdas. Okay, it is the product of eigenvalue. Okay, so when I am calculating determinant of a power n, that can be directly obtained as e power I n pi by 5 multiplied by e power I n pi by 6. This product should be equal to the 1. Okay. This product should be equal to the 1. Okay, so now let me add, if I combine these exponentials, the power will be added. Okay, so kitna hoga? 1 by 5 plus 1 by 6 will become 6 plus 5, 11, 11 by 30. 11 by 30. So e power I n 11 pi by 30. Okay, this is equal to 1. Acha, if this is equal to 1, okay, 1 is also equal to e power 0. Okay, but n is not the 0, the smallest maybe non-zero value of n they are looking for. Okay, so a power, dekho, n doesn't make sense here. N equal to 0 doesn't make sense here, because if you take n equal to 0, so a power 0 is always identity, then the question becomes irrelevant. Okay, so we not only e power 0, we know that e power I 2 pi. Okay, e power I 2 pi, e power I 4 pi, in general e power I 2 pi k बोल देता हूँ, e power I 2 pi k. Okay, Euler's identity से break करते रहे, e power I 2 pi is cos 2 pi plus I sin 2 pi, and that is equal to 1, and then 1 power k will be 1. Okay, so we can write it as e power I 2 pi k. So when you compare both the exponential powers, e power I को cancel करते हुए है, you have 11 pi upon 30 into n is equal to 2 pi into k, right? ठीक है, right? So what is the value of n? What is the value, minimum value of n? That is 2 pi into k. K का minimum value 1 ले सकते हैं ना, right? K का minimum value 1. Okay, whole multiplied by 30. Okay, divided by 11 pi. So pi to pi cancel. It's gonna be 60 by 11. Okay, it's gonna be 60 by 11. Okay, now no. The n has to be integer. Okay, they're not specified, but yeah, we'll take it to be smallest value of n, where n can be integer. Okay, where n has to be a integer. That's what I will accordingly go. ठीक है, n has to be a integer. तो अभी k के फॉर्म में ही लिखते हैं. Let me go to the next slide. Okay, so what is the result I have? इसको एक बार देख लीजिए. 11 pi by 30n. 11 pi by 30n is equal to 2 pi k. So what is the value of n? Pi cancel कर दे. That is 2k into 30. Okay, that is 60k divided by 11. Okay, so now you can take k as any integer. Take k equal to 11. You get the n lowest value as 60. The lowest integral value of n would be the 60. Okay, would be the 60. Would be equal to the 60. Done hai ji? Yes, the lowest value would be 60. Correct answer. Yes, Ankit, Ananta, correct answer. 60, the final answer. Good question this is. Okay? Okay, because the question is talking about a power n. Okay, and we related with somehow with the eigenvalue, determinants. Okay, they have given the eigenvalue of a, so we can find out the eigenvalue of a power n as per the property we just discussed. ठीक है जी? अच्छा. So now if I move ahead to the next case. Okay, now whatever property I took right now, let us solve the question first related to it. Okay, then there are some other cases to discuss. Okay, just now we have discussed this property, so another question related to it. Have a look into this. Oh, sorry, have a look into this one first. There is a matrix A, 1, 0, 2, 4. Then what are the eigenvalues of 4A inverse plus 3A plus 2y? What are the eigenvalues of 4A inverse plus 3A plus 2y? Can you tell me the eigenvalue of A directly? See Rajiv, k can be any integer in general, because I told you e power I 2 pi, e power I 4 pi, e power I 6 pi. Okay, in general that is e power I 2 pi k is any integer. Okay, but what is the smallest integral value of n? Okay, n kitna aaya tha? 60 by 11k you are taking. Okay, you can take 1, 2, 3, 4, 5, 6, anything. Okay, but when you take k 11, then you will get the answer as the smallest integral number. You can take k 22 also. Then answer will be 120, but that is not the smallest, na? So that is why we took k equal to 11. ठीक है जी? Yeah. So what is the eigenvalue of A? Can you tell directly? Yes, you can say directly, because the given matrix is a triangular matrix. Have a look into it. The elements are arranged in the lower triangle. So this is what is a lower triangular matrix. Now, what is the property related with it? Whenever you have any triangular matrix, चलो इसको भी देख लेते हैं. ठीक है? For a triangular matrix, eigenvalues are directly equal to the diagonal elements, be it upper or lower. मैंने सिर्फ triangular बोला. It is applicable for both, whether it is upper triangular or lower triangular. The eigenvalues, you don't have to put any effort because they are directly equal to the diagonal numbers. Okay, so diagonal numbers a11, a22 to a3, that is equal to the eigenvalue lambda. Okay, that is equal to the eigenvalue of lambda. So we have the eigenvalues directly, I can say. Okay, we have the eigenvalues directly, I can say. So now let me jump back to the question we are discussing. Yeah, here it is. So given the matrix A, given this matrix A 1 0 2 4, then what are the eigenvalues of 4A inverse plus 3A plus 2I? ठीक है, तो ये कितना होगा? Okay, ये कितना होगा? तो given the matrix A, what are the eigenvalues? 1 and 4. The matrix A has the eigenvalue 1 and 4 because they are equal to the diagonal numbers. Lower triangular matrix है ना? Yes, yes, yes. Eigenvalue, eigenvector is important for every branch. Okay, it is a session for every branch. Okay, be it ECEE, mechanical, civil, computer science, data science and artificial intelligence, yeah, any branch of engineering. Okay. Okay, now what are the eigenvalues of then 4A inverse? Don't solve individually, just solve it in one shot. 4A inverse plus 3A plus 2I. 4A inverse plus 3A plus 2I. क्या होगा वहां पे? You can say that. Okay, what you can say? Okay, whatever operation is applied to the matrix, same is applied to the eigenvalue. So what is going to be the first eigenvalue? 4A inverse. Okay, so 4 into 1 inverse plus 3 into 1 plus 2 into I. Okay, whenever it is identity, matrix may it will be only number 1. So only write down 2. 2 into 1, that is 2. And what is going to be the second eigenvalue? Okay, second eigenvalue of the A is 4. So for the given matrix, 4 into 4 inverse. Okay, plus 3 into the 4 plus 2. Okay, so that's going to be how much? Okay, so this is 4 plus 3 plus 2, that is 9. And this one is 4 inverse, so 1 plus 12 plus 4 plus 2, that is 15. 9 and 15. My answer is 9 and 15. Please check out, guys, option number C. Please check out option number C. Yeah, correct answer. Rahul, Bhanu, Ankit, Ananta. Correct answer. Yes, Puvarasan, correct answer. ठीक है जी? चलो, then ये important questions हैं. Now let's go to the next question, dear. Here it is, the next question. Consider the matrix A whose eigenvalues are 1, minus 1 and 3. What is the trace of A cube minus 3A square? A cube minus 3A square. Yeah, we'll come to that also, Bhanu. What is the trace of A cube minus 3A square? Now listen to me. Okay, sometimes you may get the feeling ki, okay, matrix A is given, then I will form A cube, then I will form 3A square, then I will subtract and then I calculate trace. It's absolutely lengthy. It is absolutely lengthy. But what you can do is, question is related with trace, and trace is sum of eigenvalues. But whose eigenvalues? A cube minus 3A square. Okay. Now, dekho, there is a matrix A given, 3 cross 3, whose eigenvalues you can calculate also. I have given you the beta 1, beta 2, beta 3 method. You can calculate the eigenvalues. But they have even given the eigenvalue. That means this question is purely testing the property. It is purely testing the property. Eigenvalues are given. Okay. So, if A has the eigenvalue that is given by 1 and minus 1 and 3, what are the eigenvalues of A cube minus 3A square? कितना हो जाएगा? First one, 1 cube minus 3 into 1 square. See, whatever operation applied to A, same applied to the lambda. So A cube means lambda cube, A square means lambda square. I'll do. For the second one, second eigenvalue is minus 1. So minus 1 cube minus 3 into minus 1 ka square. And third one is 3. So that is 3 cube minus 3 into 3 square. Okay, so this is gonna be 1 minus 3, that is minus 2. One of them is minus 2. The next one is minus 1, minus 3. So this is like minus 4, and the next one is 3 cube, 27 minus 3, 9. Okay, so this is 27 minus 27. This is 0. Okay, so what is the trace now? Okay, what is the trace for this matrix? Sum of the eigenvalues, that is minus 2, minus 4 and 0. The answer should be minus 6. Numerical answer type question, the answer is minus 6. Okay, so yeah, we have the correct answer. Rahul, Ananta, Shravani, Puvarasan, Bhanuprakash, Ankit, Hari, Satish. Correct answer, dears. Good going. Great going. And if you're learning, if you're enjoying, you're attempting the question, do not forget, even though like the session, keep hitting the like button. Okay. Also, please hitting the like button. Okay, ji. Now, there was one doubt in between. Let us come to that also. Adjoint. So for that, I will first frame a question to explain you the adjoint. Okay, so suppose there is a 3 cross 3 matrix. I will not give you the matrix, but just note down. Suppose there is a 3 cross 3 matrix. Okay, suppose there is a 3 cross 3 matrix whose eigenvalues are, okay, 2 and 3 and 5. Okay, 2 and 3 and 5. Okay. Now I ask you a question. Okay, tell me the eigenvalues of adjoint of the matrix. A 3 cross 3 matrix, suppose A, okay, has eigenvalues given to you. Find the eigenvalues of adjoint A. So how do we find the eigenvalues of adjoint A? How do we find the eigenvalues of adjoint? Dekho, how do you write down adjoint A? Adjoint, normally we use in the inverse formula. Inverse of a matrix is given by the formula adjoint A divided by mod A. So how do you write down adjoint A? Adjoint A is always written as mod A into A inverse. Mod A into A inverse. Clear? Mod A into A inverse. What is determinant of A? That is not given, but can we calculate that? What is the determinant of A, dear? The determinant of A is equal to product of the eigenvalues. That is 2 into 3 into the 5. That becomes 30. Okay, so now I can say that adjoint A, okay, is equal to, in this case, 30 A inverse. Mod A into A inverse is always true, but here mod A is 30. So that is 30 A inverse. Now, how do you find out the eigenvalues of 30 A inverse? I hope you have understood what to do now. Okay, the eigenvalues of A are given to me as 2, 3, 5. Okay, so eigenvalues for 30 A inverse, and that is going to make your adjoint matrix is going to correspond to 30 into A inverse. That is 1 by 2. 30 into A inverse. A inverse eigenvalue is 1 by lambda, no? Just reciprocating all of them and then eventually multiplying by the 30. So my eigenvalues are 30 by 2, that is 15. One of them is 15, one of them is 10, one of them is 6. 15, 10, 6. 15, 10, 6. Okay, that is the 15 and the 10 and the 6. That is the right answer. Clear, everybody? That is the right answer. ठीक है जी. Chalo, let's move ahead and jump to the next question. Another question. Just a second. So where should I go now? Yeah, kindly attempt this question. The eigenvalues of a 3 cross 3 matrix, of a 3 cross 3 real matrix are 2 plus root minus 1 and 3. Find the determinant of the matrix P. Important word here is real matrix. If you just remember that, your question is solved. If you just remember this, your question is solved. The eigenvalues of a 3 cross 3 real matrix P are 2 plus root minus 1 and 3. What is the determinant of P? What is the determinant of P? Okay. No, then we can't use that formula. It will exist. Okay, it will exist, but you can't use that formula because A inverse will not exist. Because the A inverse will not exist. So you have to take care of that fact. Because if the matrix is singular, Okay, if the matrix is singular, okay, अब singularity में भी depend करता है whether the rank of the matrix is n minus 1 or less than n minus 1. Accordingly, the adjoint A is formed. Okay, accordingly, adjoint A is formed. Yeah, definitely one of them will turn out to be 0, but we can't say all 0 because you are using mod A into A inverse and A inverse does not exist there, Gajendra. ठीक है. Aman, yeah, the harsh reality is yes as of now, but let's wait for maybe 1 or 2 days. By Monday, Tuesday, if there is some changes, maybe that can go into the students' favor. Okay. So, yeah, let's talk about this. What is the real matrix? Okay, I told you one thing about real matrix already discussed, that if there is a complex eigenvalue, 2 plus under root minus 1 and under root minus 1 is like iota. Okay, then it will always be in conjugate pair. Okay, and we have the answers already coming up in the screen. So that is always in the conjugate pair. Okay, so there is a matrix P, okay, which is 3 cross 3. So it should have the 3 eigenvalues. One of them is 2 plus I, one of them is 3, and one of them is not given. Okay, so this not given, this not given is the conjugate of 2 plus I. 2 minus I, alpha minus I beta. That means P has the eigenvalues now 2 plus I, 2 minus I and 3, and then what is the determinant of P? So you are able to feel that determinant and trace based calculations are very much useful and repeated. Okay, so determinant is just product of the eigenvalues 2 plus I multiplied by 2 minus I whole multiplied by 3. So this is going to be 3. A plus B, A minus B is A square minus B square. So that is 3 minus 1, that is 5. 3 5s are 15. That is known as the 3 5s are 15. ठीक है जी. ओके जी, डन है. ओके, चलिए next question. Now let's touch the next variety where you learn again something new. Okay, and then after some time we'll come to the eigenvector based calculation as well. Don't worry, I know they are still awaited. Chalo. Yeah, let's come to this. A matrix containing all ones. A special question. Okay. Ananda, थोड़ा कम frequency से test दीजिए, but देते रहिए. Don't totally give it up. Okay. Maybe once in few days also try to manage like that. And then once the sem exam is over, you can jump back. ठीक है. चलिए guys, come on here. What is the number of distinct eigenvalues for this matrix? What is the number of distinct eigenvalues for this given matrix? What is the number of distinct eigenvalues for the given matrix? Okay. How many distinct eigenvalues it is going to have? It is going to have. Chalo. So let's figure out how many distinct eigenvalues it is going to have. Just a second. So I'll tell you two methods here. Okay, let's learn two methods here. One is dear method number 1. Okay, so here there is a n cross n matrix given. To explain you the method 1, let's just try with n equal to 3. Okay dear, so if I take n equal to 3, what is the matrix? 1 1 1. I just try to create a simple matrix 1 1 1 1 1 1 1 1 1, and then I'll tell you the general method also. Now for a 3 cross, see why I am taking 3, because you know na, for 3 cross 3 characteristic equation you know na. Okay, the beta 1, beta 2, beta 3 calculation. Okay, so what is the beta 1? That is the trace 1 plus 1 plus 1, that is equal to 3. What is the beta 2? So please remember, okay, because all rows are identical, so whenever you calculate any minor, suppose you take the first diagonal element, okay, what is the minor? 1 minus 1. If you delete first row and first column also, then 1 minus 1. Okay, even similarly if you take second, okay, then also 1 minus 1. So all the minors are 0. Okay, all the minors are 0. Okay, so beta 2 is 0. And definitely what is beta 3? Determinant is anyway 0, because even if any two rows are identical, then the determinant is 0. Here all three rows are identical. Okay, the determinant is 0. So what is the only characteristic equation, dear? What is the only characteristic equation? What is the only characteristic equation? Okay, that is given by lambda cube minus beta 1 lambda square. Okay, plus beta 2 lambda minus beta 3, no need to write, only this much. Okay, lambda square, lambda minus 3, lambda square common, lambda minus 3 is 0. So lambda square hai, there is a factor of lambda square. So I can say that lambda is 0, 0, 3. How many are distinct? How many are distinct? Only 2 distinct. Okay, only 2 distinct. One of them is repeated. Okay, now still there will be a doubt. See, this is a general method to calculate the eigenvalues. Okay, I was just showing you one method. But by this method, at least for n equal to 3, I can't say the answer because there are 2 distinct. So should I select answer as 2 or should I select the answer as n minus 1? Because here n minus 1 is also 2, na? So whether it is actually 2 or whether it is n minus 1. Okay, so why I told you this method, isse answer to nahi aayega, but why I told you this method is this is one method to calculate the eigenvalues, not about distinct or undistinct, to calculate all the eigenvalues, okay, of a given matrix, okay, especially this 3x3 format. Okay, now let's come to the method number 2. Okay, now let us come to the method number 2. Let us take the general order, whatever it may be given. Okay, whatever, n cross n, 5 cross 5, 10 cross 10, whatever they want to give. This is n cross n. ठीक है. Yeah, you can try for 2 also, Gajendra. Now let us come to general method so that we learn something new here. A matrix has all elements 1. Acha, all elements 1 eventually means eventually all the rows are same. All the rows are just identical to each other. Okay, all the rows are identical. I can say R2 is R1. I can say the third row is also R1. Let us take the reference as R1. Okay, I can say that all the rows are just equal to R1. All the rows are just equal to R1. So dear, whenever all the rows are identical, then what happens? R2 is R1, R3 is R1. So, you know, there is only one independent row. Rest all are dependent on that. Rest all are dependent on R1. Okay, so whenever all rows are identical, so I am able to feel there is only one independent row. There is only one independent row. There is only the one independent row. Okay. So, now what is the rank of the matrix? What is the rank of the matrix? What is the rank of the matrix? Tell me. What is the rank of the matrix? What is the rank of the matrix? Can you tell me what will be the rank of the matrix here? Yes, rank of a matrix is equal to number of independent rows. Rank में पढ़ा होगा आपने, नहीं पढ़ा है तो सुन लीजिए. Rank of a matrix is equal to number of independent rows or number of independent columns. So here it is only one independent row, so rank will be 1. Okay, now a next property which will be connecting rank and eigenvalues. Have a look into this. The connection between the rank and the eigenvalues. The rank of a matrix is equal to number of non-zero eigenvalues of the matrix. There is a connection between rank and eigenvalues. The rank of a matrix is equal to number of non-zero eigenvalues of the matrix. Clear? Okay. The only exception to this property is triangular matrices. If there is a triangular or diagonal matrix, please discard this. Otherwise, in general, rank of a matrix is equal to number of non-zero eigenvalues. Okay. So that means, I can say that there will be only one non-zero eigenvalue. There is only one non-zero eigenvalue. Acha, there are total n eigenvalues. Okay, but out of them there is only one non-zero eigenvalue. Okay, out of them there is only one non-zero eigenvalues. So what will be the set of eigenvalues? There are n eigenvalues, only one non-zero. Okay, so rest all are 0. Only one non-zero, and suppose that is lambda. Only one non-zero, suppose that is lambda. Okay. These are all zeros and this is the non-zero eigenvalue. Only one non-zero. How to find that non-zero eigenvalue? How to find that non-zero eigenvalues? Dear, again apply the property sum of lambdas is equal to trace. Okay, sum of lambda. So sum of lambda is simply lambda only because rest all are 0. And what is the trace of the matrix? Trace is sum of diagonal numbers 1, 1, 1, 1, 1, 1, 1. How many diagonal numbers are there? It is n times n times. So, you know, the sum of diagonal elements is n, and hence lambda equal to n. Okay, so what is the set of eigenvalues? The eigenvalues of the given matrix are 0, 0, 0, 0 and n. All are 0, only one non-zero. Okay, acha, how many are distinct then? Still there are only two distinct eigenvalues. Okay, n and 0. ये सब repetition में चला जाएगा. If you count about non-repeated, if you count about distinct eigenvalues, one of them is n, one of them is 0. Rest all other zeros are repetition. Okay, so how many distinct? Okay, how many distinct? It is only 2. That is a generalization. So correct answer is 2 only. Okay, here also you see directly the eigenvalues now. 0, 0, n I told you, na, 0, 0, 3, because it is a 3 cross 3 method number 1 which I took. So that is why the eigenvalues are 0, 0, 3. That is why the eigenvalues are 0, 0, 3. Correct hai ji? That is a 0, 0, 3. Done hai. Okay. Chalo. So then let's be ready for the next question. Okay, this is good. Acha, related to it, na, let me link a question here. You know, you can expect a question out of this. Is concepts are related. There have been questions in GATE also related to it. Let me see if you can answer. Let me see if you can answer. Let me see if you can answer. Suppose I give you a question. It is a determinant based question, but let's see. Okay, if you are able to solve it. Such questions have been there in competitive exams as well. 5 cross 5. Directly calculating the determinant of 5 cross 5, you also know it's going to be tedious. It's going to be lengthy. Okay. So can you tell me this answer now quickly? Just allow me a minute. Yeah, dear. So let's see what have you solved. Here only Devendra. Yes. Anybody with the answer? Dekho, if you solve it directly the determinant way, if you solve this question directly the determinant way, ये थोड़ा सा time consume करेगा. Okay, but you can observe this. Okay, you can observe this and you can write down the given matrix as only difference is here all the diagonal elements are 2. If all the diagonal elements are 1, then I know I know something can be done. Okay, so what I can do, the given matrix A can be split na sare diagonal element. Acha, if you take all diagonal also 1, then all elements actually become 1. Okay, and then add separately identity to it. Identity where all diagonal elements are 1. Correctly? Okay. Now, okay, so you can add and then you get the matrix A. Okay, so now I am able to talk about the case that suppose A is equal to some matrix B plus identity. Do I know the eigenvalues of B? Do I know the eigenvalues of B? Just now we discussed, na? A matrix containing all 1. So eigenvalues are 0, 0, 0, 0, n, and n is 5. So eigenvalues of B are known to me, 0, 0, 0, 0, 5. Okay, so A, which is nothing, B plus I. So if you know the eigenvalues of B, you can calculate for B plus I. Na? You can calculate for B plus I. There is nothing great there. So yes, you can calculate there for B plus I. Okay. So what is the eigenvalue for B plus I? Add 1. Okay, it's going to be lambda plus 1. All eigenvalues will be added by 1. So this becomes 6. Now, the eigenvalues of the matrix A are known to me. That is 1, 1, 1, 1, 6. So what is the determinant of the matrix? Is product of the lambdas, and product of this becomes 6. 1, 1, 1, 1, 6. Product of them becoming the 6. That's the answer. That's the answer. Solving it eigenvalue way. If you solve it determinant way, it's going to be lengthy. Okay, by applying elementary row or column operation, it's going to be lengthy. Okay, solving it eigenvalue way, conceptual and little, you can say time saving method. That's going to be the time saving method. Done hai ji? Chalo. Okay, let's go to the next then. Let us go to the next case here. Yeah, look into this. Consider the 5 cross 5 matrix given to you. Okay. Again, 5 cross 5, calculating the eigenvalue by proper method is lengthy, but let's read what they are trying to say. It is given that A has only one real eigenvalue. Given A has only one real eigenvalue, so rest all will be complex. Then what is that real eigenvalue? What is that real eigenvalue? Dear, what is the observation about the rows? What is the observation about the rows? It is 1, 2, 3, 4, 5. Then again 1, 2, 3, 4, 5 here. That means circular rotation is there. Okay. Again 1, 2, 3, 4, 5. Again circular rotation is there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All elements of the rows are just identical. They have been rotated. Okay, they have been rotated. Acha, because they are identical. Okay, what is sum of each row? 1 plus 2 plus 3 plus 4 plus 5. All elements just they are rotated, shifted here to there, but the elements nature is same. So if you add, okay, here I can say that looking into the matrix that sum of elements of every row is 1 plus 2 plus 3 plus 4 plus 5, that is 15, and that is same. So next concept, next property of eigenvalue. Hi Guru Krishna. Next property of the eigenvalue. If the sum of elements of every row, every column, you can apply to column as well. Okay, so if the sum of elements of every row is same, then one of the eigenvalues is always equal to that sum. One of the eigenvalue is always equal to that sum. Okay, that means one of the eigenvalues, one of the lambdas will be equal to that sum, and that sum is 15. Okay, one of the eigenvalue will be 15. Acha, this is by chance real. And then question says that A has only one real eigenvalue. That is the additional information given to you. Okay, so I have one eigenvalue which is already real. Question says there is only one real eigenvalue. So what is that real eigenvalue? 15. What is that real eigenvalue? That is going to be 15. That's it. What is a single eigenvalue? It is just equal to the 15 here. ठीक है. If sum of the eigen, देखो अनंता, if sum of the elements of every row is same, like here 1 plus 2 plus 3 plus 4 plus 5, okay, again 5 plus 1 plus 2 plus 3 plus 4, सभी rows को आप add कर दो, okay, you get 15, and whenever it is same for all the rows, okay, then one of the eigenvalue is equal to that sum, is equal to that addition, okay, so one of the eigenvalue will be 15, okay, and that is already a real, and matrix has only one real eigenvalue, ठीक है, that is what it is. Right, good morning Bhaskar sir. Welcome to the session. So let's go ahead, moving ahead to the next question then. Okay, let's get moving ahead to the next question then, and let us be taking the next question now from let's come here. What is the value of k? What is the value of k such that the vector 1 to k is an eigenvector? See, whether it is MCQ question, whether it is MSQ question, or whether it is NAT type question. Okay, whether it is NAT type question, you have to remember that whenever the question is on eigenvector, okay, then the value of k, whatever they ask, just use one approach. Eigenvector ax is equal to lambda x. What is the eigenvector? A vector x which satisfies ax equal to lambda x. Okay, the output of the system A for the vector x is proportional to the vector x. Okay, those special vectors are the eigenvectors. So you just have to solve this equation, ax equal to the lambda x, because this is a given eigenvector. Okay, I'll take the matrix A, that is 4 1 2. Let us apply and solve. Then 17 2 and 1, and then 14 and minus 4 and 10 multiplied by the x. Okay, should be equal to, given it is an eigenvector, so it should be compulsorily equal to lambda into k. Okay, lambda into x. Okay. Why previous question determinant is 3? Oh, just a second. Yes guys, please solve this. Just a second, I'll put back my mic again. Yes dear, tell me. So here, okay, so now let's start solving it. Okay, so multiply first row, first column, so 4 plus 2 plus 2k, that is 6 plus k. Next I guess 17 plus 4, 21 plus k. Next is 14 minus 8, that is 6 plus 10k. This should be equal to how much? Send the lambda inside, so lambda, 2 lambda and lambda into k. I need the value of k. No problem. First equate the first row, so I get, what is that lambda? That is also unknown, but we can solve it up. Okay, so according to the first element, okay, two vectors are equal, so all corresponding elements are equal. Okay, all corresponding elements are equal. So 6 plus k is equal to lambda. Okay, and then 6 plus 10k. Okay, 6 plus 10k. Yeah, इन दोनों को subtract भी कर दोगे ना, first and second को, तो you get lambda. It becomes more simple. Okay, 6 plus k is lambda. 21 plus k is equal to 2 lambda. Okay, इसको subtract किया, so k gets cancelled. 21 minus 6 will be equal to 2 lambda minus lambda, and hence lambda is 15. ठीक है, if I don't want lambda, I want the k. Okay, then I go for the third one, that is 6 plus 10k is equal to lambda k. Okay, so 6 plus 10k is equal to 15k. Okay, that means 5k is equal to 6. Is that okay? Yes, 5k equal to 6 and k is 1.2. No. There is some problem, I think. 6 plus 10k. Let me check it out, guys, once again. 412. Okay, so that is 4 plus 2 plus 2k. Sorry, that is 2k. That is 2k. A typo error, I think, has come up here. 4 plus 2k. Okay, let me recheck it. 17 plus 4, 21 plus k. This is correct. 14 minus 8, 6 plus 10k is 1, 2k. So lambda, 2 lambda and lambda k. So I'll have a correction here. Okay, this is also 6 plus 2k equal to the lambda. Okay, so directly I want k. I'll try to solve from here only. Okay, there was a typo error, guys, so just I have corrected it and then we'll be getting the answer. Okay, so what I can do is isko bhi into 2 kar dete hain, so 12 plus 4k is equal to 2 lambda, and now you subtract, so this becomes 9. Okay, 9 minus 3k will be 0, and hence k should be equal to the 3. Check it out, guys, k should be equal to the 3. Correct. Yeah, Pooja, that's what it is, 6 plus 2k. Okay, right. Right. Chalo. So k will be 3. We wanted k is opted. Okay, then suppose if you want lambda by chance if you want lambda, if the question asks you, to ye kitna ho jayega? 4 plus 2k is equal to lambda. So lambda is like 4 plus 2 into 3, that becomes 10. Okay, what is the corresponding eigenvalue? Okay, if x is the eigenvector, lambda is the corresponding eigenvalue. So I can tell you lambda equal to 10 is the corresponding eigenvalue corresponding to the given vector. This is known as the corresponding eigenvalue. Okay, this is the corresponding eigenvalue. Okay, now let's take another question here, dear. Let us take another question here. Yeah. And let me add on to the point that this is a MSQ question. Okay, normally from eigenvectors easily MSQ question can be framed. Okay, yeah, Bhanu, 6 plus 6 क्यों बोल रहा हो? Any error क्या still? अरे why type या calculation error is happening again? Oh my god, why it is happening again? चलो, I'll just put it again यार, वो एक बार हो जाता है ना, so then it is going in the flow. I think just forget this, dear, just forget this. Okay, I'll just do it again. Okay, so yeah, correct, 4 plus 2, that is 6, and then plus 2k. Okay, then 17 plus 4, 21 plus k. Okay, just sorry for that. 14 minus 8, 6 plus 10k. Now this is equal to lambda, 2 lambda and the lambda k. No issues. Okay, and now I will solve up here. So I have 6 plus 2k is lambda. At the same time, 21 plus k is 2 lambda. And I'll directly put this value of lambda here from the above equation, that is 6 plus 2k. Okay, so 21 plus k is equal to 12 plus 4k. Okay, and the value of 3k is 9. K is still equal to 3. Okay, k is still equal to 3. Okay, so by chance k is still equal to 3, no problem. Okay, but now that is correct. And if k is equal to 3, then I have 6 plus 2k. Yahan zarur correction hoga. Okay, so this is gonna be 6 plus 2k is lambda. So 6 plus 2 into 3, the corresponding eigenvalue is 12. The corresponding eigenvalue is 12. That will change. ठीक है जी? All okay now? All okay? Okay. Great to know, Bhaskar sir. ठीक है, that is what it is. So this is just a small calculation thing that happened. Yeah. So let's come to this question. MSQ question, as I'm telling you, very easily can be framed here. Let us come to that MSQ question. Okay, which one of the following is or are? Okay, A kya X is other, because it is a 4 cross 4 matrix. It can have 4 eigenvalue and 4 eigenvectors. So they can ask multiple choices, na? Okay, for the given matrix below, which of them can be the eigenvector? And question related with the eigenvector. Okay, whether it is NAT or either MCQ or MSQ, you just have to try one thing, as I have mentioned you, that is AX equal to lambda X. Okay, AX equal to lambda X. So only thing is 4 cross 4, little calculation. बहुत ज़्यादा नहीं बोलूँगा. Okay, but yeah, we can deal with it. So what I will do is, guys, just let us take this matrix here once again. Okay, take this matrix here once again. Yeah, shall we do it here only? Okay, guys, I'm doing it here only. Okay, I'll just write down the 1 by 1 vector. I'll just write down the 1 by 1 vector. -1, 1, 0, 1. Okay, now look into it. look into the multiplication here only rather than writing it multiple times. इसको यहीं देख लेना. Okay, so minus 9 into minus 1. Be careful with the calculations. Okay, minus 9 into minus 1 will be 9, minus 6 and minus 4. So 9 minus 6 minus 4. Next आ गया minus 8 into minus 1, that is 8, then minus 6, then minus 1. Okay, next minus 20. Okay, then you have plus 15. Okay, and then you have this is 0 and then you have 5. Next देख लेंगे 32, that is minus sign के साथ, तो minus 32. Okay, minus of 32 plus of 21. Okay, and then plus of 12. Now let's see what is the result here. Let's see what is the result here. 9 minus 6 minus 4, that is minus 1. 8 minus 6 minus 1, that is 1. This is 0. Okay, and this is equal to 33. This is 1. Now, what is the result you have got? What is the result you have got? Please see everybody. What is the result? I multiplied with the given vector x. I am assuming A is the correct option. So, it should satisfy Ax equal to lambda x if it is the eigenvector. If it is the eigenvector. So, check करते हैं. I multiplied Ax and I am getting x. What does it mean? What does it mean? I am multiplying A with x and I get x for the option number A. So that is eigenvector. Now lambda can be any number. Lambda is 1 here. Okay, Ax equal to x simply means that this is the correct eigenvector with the lambda equal to 1. With the lambda corresponding eigenvalue is equal to 1. Done? Eh? Now I will try the next one. Here only guys. So I am erasing it. Okay. I am erasing it and now I will try the next one here only. Okay, parallelly. So next is what? 1, 0, minus 1, 0. 1, 0, minus 1, 0 simply suggesting कि ये first and then minus third. Okay, first and minus third. Okay, so minus 9 minus of minus 2, minus 7 आ गया. Okay, this is minus 8 minus of minus 3, that is minus 5. Okay, 20 minus 8, 12. 32 minus 7, 25. Okay, is it somehow equal to the given lambda into given vector? Is it somehow equal to the given vector lambda 1, 0, minus 1, 0? Is it somehow possible? All rows are taking, na Jaya? Okay, every row with column. Okay, how do you multiply? First row with this column, second row with this column. Okay, great to know, Mukul. Okay, so now tell me what is the answer. Is this possible first of all? Is this possible? Suppose if this is possible, if you equate first to first element, so lambda will be minus 7. But if lambda is minus 7, so how lambda into 0 can be minus 5? No, they don't match. Okay, they don't match because if two vectors are equal, all corresponding elements should be equal. That is not possible. That is not possible. Okay. So option number B is definitely not correct. Okay, for option number B, when I have tried Ax, doesn't turn up to be lambda x. Now option number C, here only let us try option number C. Okay. Little bit time taking, but yeah, that's okay. Okay, so now take this here, the first row, देखो, minus 9 into minus 1, that is 9. Okay, then minus 4, 2 into minus 2, and then this is minus 8. Next element आ जाएंगे, minus 8 into minus 1, 8. Then 3 into minus 2, minus 6, minus 1 into 2, minus 2. Correct है? Then 20 into minus 1, minus 20. Then 8 2s are 16, 5 2s are 10. Last, minus 32, 7 2s are 14, plus 24. Let's see the numbers now that is coming up. Okay, 9 minus 8, 1, minus 4, minus 3. 8 minus 6 is 2, 2 minus 2, 0. Okay, perfect. 0 aa raha hai. Then this is 26 minus 26. Okay, 38 minus 32, this is 6. Yes, dear, correct. This is also the eigenvector. Okay, yes. If you can take what? If you can just take 3 common. If you take 3 outside, so minus 1, 0, 2, 2. Take 3 outside, dear. Minus 1, 0, 2, 2. If you take 3 outside, minus 1, 0, 2, 2. I have got the answer. Okay, minus 1, 0, 2, 2. That means in the option number C, when I have tried Ax, I am clearly getting 3x. So x is the correct answer. First of all, let me tick mark the question. X is the correct answer. It is the correct eigenvector. Corresponding eigenvalue will be 3. They are not asking eigenvalue, but in addition, let us write. There will be other also, but 1 is surely an eigenvalue. Na? Otherwise, the whole concept fails, Gajendra. You tell me why we can't say 1 is the eigenvalue. I am not telling 1 is the only eigenvalue, but one of the eigenvalue corresponding to the vector in the first option is 110% 1. Even if you try modulus of A minus lambda I here, You apply that operation, 200% 1 will come, and now 200% 3 will also come. Okay, whatever eigenvalues you get from here, they are the final eigenvalues, dear. Okay, they are the final eigenvalues. उसमें कोई deviation नहीं होगा. Okay, similarly option number D. Okay, similarly the last case, that is the option number D, and that is given by 0 and 1 and -3 and 0. Okay, so this is, देखेंगे, -6, okay, this becomes +6, 0, okay, then -6, and then this becomes 9, okay, -9 minus 6, 3. Next is 15 minus 24, so -9. Next is 21 minus 21, 0. Perfect. Here also you take 3 common. Okay, so you have 0, then 1, minus 3, 0. Ax equal to 3x. Okay, this is also an eigenvector. This is also an eigenvector. Correct. So for option number D, okay, also when I have tried Ax, that is equal to the 3x. Okay, corresponding eigenvalue is 3. Corresponding eigenvalue is 3. ठीक है? Okay, done. Acha. Option number B is the only option where I try, I get Ax not equal to lambda x. So correct answer, I told you, this is a MSQ question, multiple select question. One or more than one answer can be correct, and answer to be marked is A, C, D. All three you mark, then only you get the answer. Then only you get the marks actually. Then only you get the marks, correct marks. Okay, ji, next question then. Next question should be ready for us. Let's get going ahead to the next question then. Okay, so before I take the next question, guys, a quick update for all of you. Okay, a quick update for all of you guys that yes, already it is Sunday, that is 3rd December today. BYJU'S National Scholarship Test is live on the BYJU'S Exam Prep app, in which you participate and you can get huge benefits like up to 90% scholarship on the GATE and engineering services complete preparation courses. So they can be a bumper chance for you. Based on your performance, you'll be getting the scholarships provided. So on the app, you can appear anytime today till 9 PM. Register on the app. And also guys, okay, the free live interactive workshop coming up this Wednesday, 6th of December, by all your favorite, my favorite Abhinav Negi sir at 7:30 PM. Okay, and for all the GATE 2025 aspirants who have just started, you're willing to start, what is the roadmap to be a topper? Okay, what should be the complete roadmap to be successfully become a topper in the GATE 2025 examination? Insights will be provided in this particular workshop. Join again on the BYJU'S Exam Prep app. All these activities on the app. Okay, so if you don't have the app, you can get it from Google Play Store, or directly you can go to the description of this video and you'll find a link. Okay, you'll find a link where you can download the app directly. Okay, now let us move ahead to the next question here. Here it is. Can you tell me the answer here? Yes, a single eigenvalue can have, can have different eigenvectors. Yes, it is possible, Gajendra. It is possible. So what may happen now? Okay, what may happen? There can be the concept of repeated eigenvalues also. Okay, eigenvector, if you talk in the conventional sense, Gajendra and Ananta, Ax is lambda x. Okay, so A minus lambda I into x equal to 0. If you solve in the conventional way. How to solve in the conventional way if you want? See, anyways, for MCQ or for GATE NIT questions, you don't need that conventional approach. But still, if you want to see the conventional approach, you see my earlier videos on eigenvalue, eigenvector, you can find that. Okay, but right now we are able to manage all the questions with the approach I am telling today. But just I am adding, agar if you apply conventional approach, so you are solving a equation A minus lambda I into x equal to 0, just like bx equal to 0. This is a homogeneous system of equation. Okay, this is a homogeneous system of equation, and this homogeneous system of equation may have multiple solutions. Okay, definitely it may have the multiple solutions corresponding to one eigenvalue, right? It can have multiple solutions corresponding to one eigenvalue. Okay, those multiple solutions may be independent or dependent on each other. Okay, so for this, that's why I'm not going deep into it, because I have to then again come to the homogeneous system of equation also and teach you that, but you can find that on my previous videos. But as of now, Okay, to solve the question of any competitive exam, the approach I'm telling 100% applicable. But yeah, the concept you're telling, okay, कि एक ही आइगन दो ऑप्शन में एक ही आइगन वैल्यू आ रहा है, that is possible. That's what I'm adding you, confirming you. There is nothing wrong with the data. It is possible. Okay, try to think with respect to homogeneous system of equation. Okay, it can have multiple solutions. Out of those multiple solutions, how many are independent solutions? When you study ax equal to 0, homogeneous system of equation, it contains n minus r independent solutions. It contains n minus r independent solution. अगर homogeneous system पढ़ा है तो ये point याद आ जाएगा. It contains n minus r independent solutions in total. Okay, चलिए, let's come up here. What is the direct? It's a direct question, guys. Okay, what is the type of matrix? That's what you have to identify. All diagonal elements are 0, and elements above and below the diagonal are, have a look into it, plus 2i minus 2i. Okay, just opposite sign, same magnitude. 6i minus 6i, opposite sign, same magnitude. 3i minus 3i, opposite sign, same magnitude. That is what is skew symmetry in the matrix. Elements above and below the diagonal are identical, but they differ only in sign. If they are totally identical, that is symmetric. This one is skew symmetric. Okay, this one is skew symmetric. Now guys, you don't have to solve. There are very, very, very important and standard results, eigenvalues of symmetric, skew symmetric, Hermitian and etc. matrix that you should always remember, because lots of questions continuously asked from that, directly or indirectly. Okay, sometimes they directly ask as a statement also, the eigenvalues of a skew symmetric matrix are dash dash dash. Okay, they are what? They are always 0 or purely imaginary. They are always 0 or purely imaginary. Real nahi ho sakta. Only possibility is answer number C. Okay, for skew symmetric matrix, okay, lambda is either 0 or pure imaginary. Okay, it cannot be anything else. Okay, the only option number C matches. Have a look into this. The eigenvalues of a real skew symmetric matrix. Okay, the eigenvalues of a real skew symmetric matrix. Achha, sorry. This is not real. ठीक है. But still, it is Hermitian matrix basically. It is basically the real skew symmetric nahi hai. It's a complex matrix. Okay, but ठीक है. I'll add on to all the properties. Okay, skew symmetric to hai, but this is not real skew symmetric. There is nothing wrong. It is a skew symmetric matrix, but it is not real skew symmetric. Okay, if it is not real skew symmetric. ठीक है. Correct, Gajendra. उसी पे आ रहे हैं. So we have all the points. Don't worry whether it is skew symmetric or the Hermitian. So first of all, the eigenvalues. Let us revise all these points of a real symmetric matrix. They are always real. Eigenvalues of a real symmetric matrix are always real. Okay. Eigenvalues of a real skew symmetric matrix are either 0 or pure imaginary. Okay. Next, eigenvalues of a Hermitian matrix are always real. Okay, and eigenvalues of a skew Hermitian matrix are either 0 or pure imaginary. That means whether the matrix is real skew symmetric or whether it is a skew Hermitian matrix, eigenvalues are 0 or pure imaginary. If a matrix is real symmetric or a Hermitian matrix, they are always real. Okay, I hope you are clear about the types of these matrices. Okay, symmetric matrix, A transpose is A. Skew symmetric matrix, A transpose is minus A. Hermitian matrix, AQ equal to A. Skew Hermitian matrix, AQ equal to minus A. Okay, what is AQ? AQ is a notation to write down conjugate transpose of a matrix. To write down the conjugate transpose of a matrix. To write down the conjugate transpose of a matrix. अब ध्यान देना है यहाँ पे. One more point, let us revise and then let's go back to this. Eigenvalues of a unitary matrix, okay, or a real orthogonal matrix, or both of them will satisfy mod lambda equal to 1. Matlab all the eigenvalues will have magnitude that is equal to 1. Now, what is a real orthogonal matrix? In the real terms, it is AA transpose equal to identity, and for a complex matrix, we define unitary matrix, that is AAQ equal to identity. All of these types of matrices should be very clear to you. Okay, now whether it is skew Hermitian, yes, skew symmetric to hai, but this is not real skew symmetric. This is not real skew symmetric. Okay. Now, whether it is skew Hermitian, what is Hermitian? What is Hermitian? As I told you, I'll explain you this so that you revise the Hermitian and skew Hermitian also. Okay, what is the AQ? Suppose this is the matrix A. इसको A ही बोलते हैं. Okay, suppose this is the matrix A. So what is AQ? As I told you, A conjugate transpose. So what do? We take the conjugate of every element and then take the transpose of the matrix. Okay, दोनों एक ही साथ कर लेते हैं. Okay, so देखो 0, 0 conjugate is 0. What is the 2i conjugate? Minus 2i. That should come here. That should come here. That should come up here. Please remember, that should come up here. Okay, this is minus 2i because transpose bhi lena hai na. So first row I'm writing in first column and every element is conjugated. 3i conjugate minus 3i. Now let us come to this. Okay, second row will be written in second column. Minus 2i conjugate is 2i, then 0, and 6i conjugate is minus 6i. Next, third row pe aa jayenge. Okay, so minus 3i conjugate will be 3i, minus 6i conjugate will be 6i, okay, and then 0 conjugate is 0, and they are exactly identical of each other. They are exactly identical of each other. Okay, they are exactly identical of each other. AQ is equal to A. Okay, AQ is equal to the A. And what is the type of this matrix? If AQ is equal to A, that is a Hermitian matrix. Dear, if AQ is equal to A, that is a Hermitian matrix. Okay, now I told you eigenvalues of a real symmetric matrix or a Hermitian matrix, they are always real. So eigenvalues should be real. Okay, all the lambdas should be real. Okay, that means isko to neglect kar denge. That is not the correct answer. It should be real. But which real option now? I have A, B and D. I have the A, B, D. Which real option? Okay, now you can check the trace also. Okay, you can check the trace also. Okay, what is the trace? Eigenvalues are real. Okay, eigenvalues are real. So that is either A, B or D. Okay, it is A, B or D. But if you check the trace now, the trace should be 0. Okay, the trace should be 0. So whether the trace is 0, only this option trace is 0, B mein 0 nahi hai, D mein 0 nahi hai. Okay, right. So sum of eigenvalues should be equal to trace, sum of lambdas equal to trace. Okay, trace is 0. Only option number A will satisfy. The correct answer is A. Correct answer is A. Okay. Now Gajendra. Okay. Complex eigenvalue come in conjugate pair. By the way, this option C is not correct here, but still let me explain you. Even if this was the correct answer, why it doesn't hold here? I told you complex conjugate pair occur in complex eigenvalue occur in conjugate pair for which type of matrix? You are missing that point. It is only for real matrix. I also repeated that for a complex matrix, conjugate pair not come. Okay. So that conjugate pair property is only for real matrices. Yahan par real hai nahi. Okay. So I can call this matrix as skew-symmetric. Okay. But this is not real. So don't use the property. Okay. The property is very carefully. The property is very carefully for real skew-symmetric matrix. For real skew-symmetric matrix. Dhyan dena. This is skew-symmetric but not real. Okay. It is actually a Hermitian matrix that has turned up in front of us. It is a Hermitian matrix that has turned up in front of us. Clear? Okay, good evening, good morning, Ashok. Chalo. Then, so any doubts with respect to this question, definitely let me know. If any doubts with respect to this question, definitely let me know. Okay, yeah. Next question. The matrix A has 4 distinct eigenvalues and one of the eigenvectors is given to you. It has 4 distinct eigenvalues. Okay, and one of the eigenvectors is given to you, then which one of the following can also be another eigenvector? Related to eigenvector only. Which one of the following can be another eigenvector? Can be another eigenvector. Which one of the following can be another eigenvector? Can you tell me? Dekho, what is the type of matrix here? Okay, let us separate the diagonal elements. Okay, now elements above. It is purely real matrix, number 1. It is purely real. All elements are real. Now elements above and below the diagonal. 2 and 2 same. Okay, 3 and 3 same. Okay, ye 4 and 4, they are all symmetric. Okay, then this 4 and 4. Okay, this 3 3 also makes symmetry. 1 and 1. Elements above and below are just mirror image of each other. Elements above and below the diagonal are mirror image of each other. There is the symmetry without any sign change also. Okay, so matrix A is number 1 real. Okay, and number 2 point, it is symmetric as well. It is real symmetric matrix. Okay, now with real symmetric matrix, actually 2 important points you should remember. Number 1, I already told you, for a real symmetric matrix, eigenvalues are always real. Eigenvalues are always real. Okay, but they are not asking the eigenvalues. Pata hona chahiye, but they are not asking the eigenvalue here with respect to eigenvector. Next, a very important property here once again, the eigenvectors corresponding to distinct eigenvalues. Please take care of this important word. Corresponding to distinct eigenvalues of a real symmetric matrix will be orthogonal to each other. Eigenvectors corresponding to distinct eigenvalues of a real symmetric matrix will be orthogonal to each other. Okay. Now, what is very clearly given that this has 4 distinct eigenvalues. They are not expecting you to calculate the eigenvalues and check whether they are distinct or not, but they have given it has 4 distinct eigenvalues. Okay, right. So if there are out of the 4, okay, out of the 4 there will be 2 eigenvalues, suppose lambda 1 and lambda 2, and the eigenvectors corresponding to it will be orthogonal. But here all 4 are distinct. All 4 are distinct. So what I can say, okay, if all 4 are distinct, okay, if all 4 are distinct, so all 4 corresponding vectors, all, what is happening here? All 4, all 4 corresponding what? Eigen, some error happening, eigen vectors will be what? Will be orthogonal. Orthogonal. Okay. Acha, how do you check vectors are orthogonal or perpendicular? How do you check the vectors are orthogonal or perpendicular? Okay, suppose there are 2 vectors, okay, x and y. Okay, suppose these are any 2 vectors. Okay, how do you define their dot product in the matrix form? Okay, their dot product is written as x transpose y. Their dot product is written as x transpose y. Okay, and if x transpose y is 0, dot product is 0, then we say that x is perpendicular to y, because dot product is 0 for perpendicular vector. That is the basics we know. Okay, so one of the eigenvector is 1 1 1 1, which can be another eigenvector. So which of them can be another eigenvector? Which is orthogonal to it, because all 4 eigenvectors should be orthogonal. One is given, the next one should be, next name, actually all 4, but you have to find only one here. It should be orthogonal. Okay, so let us say this is x. Okay, for the option number A, if I apply x transpose y, how do you calculate dot product? Corresponding numbers are multiplied, na? Corresponding numbers are multiplied. Okay, say for example, let me explain you for once. Suppose this is x1, x2, x3, x4. Whether it is 4th order or 3rd order, anything. Suppose y is y1, y2, y3, y4. What is the x transpose y? How do you calculate dot product? Corresponding first to first element x1, y1. Okay, then you calculate x2, y2. Then you add x3, y3. And then you add the x4, y4. That is how you calculate the dot product or inner product. Okay. So here, what is the result? 1 into 1, 1 into 0, 1 into minus 1, 1 into 1. Is it equal to 0? No, net it is not equal to 0. Option number B, x transpose y. Okay, so dekho, 1 into 1, next is again 1 into 1, next to 1 into minus 1, and again last is 1 into minus 1, 0. Okay, my answer is definitely B. My answer is definitely B. Okay, for the option number C, it is clearly 1 plus 1 plus 1, that is going to be 3. For option number D, 1, 1, 1 and then minus 1. Okay, that's also not going to be 0. Okay, no, this is only MCQ. MCQ. Only B will match here. Okay, this is MCQ only. Achha, anyways, it can be MSQ also. Right now we made it as chalo isko MSQ hi bol dete. Chalo. Let me call it as MSQ question. Okay, and tell you one more important point. And because it is MSQ, it is my moral responsibility to check all the results. So yahan kitna aa gaya? 0 and then 1, 1, 1. This is 3. This is also not equal to 0. And for the last option, you will get x transpose y, 1 into 1, then 1, and last mein minus 1. This is equal to 2. This is also not equal to 0. So only option number B. But still it can be MSQ. MSQ means one or more than one can be correct. Don't be puzzled, okay? It can be MSQ where one or more than one answer can be correct and answer is only B. And ऐसे questions आए हैं gate में. Please take care. Sometimes in MSQ also only one option correct. In MSQ also only one option correct. Okay. Eigenvectors, see this is the property Bhanu. Eigenvectors which are corresponding to distinct eigenvalues of a real symmetric matrix will be orthogonal, perpendicular to each other so that their dot product is 0. Okay, so that their dot product is 0. I can put it like this. Okay, suppose there is a matrix A, it has eigenvalue lambda 1, okay, and it has the corresponding eigenvector x1. It has another eigenvalue lambda 2 and it has the corresponding eigenvector x2. Okay, this property says that for distinct eigenvalues, if lambda 1 not equal to lambda 2, that is important, distinct word is important, okay, then x1 is perpendicular to x2, orthogonal, and that means dot product x1 transpose x2 should be 0. This is how we can write this property mathematically. x1 transpose x2, that is the dot product should be the 0. Okay, this is what is the important property here. Okay, next question here. Chalo. Let A be a 3 cross 3 singular matrix with two of the eigenvalues as 2 and 3. What is the number of linearly independent eigenvectors of AQ plus 2A plus I? Now, first of all, listen to me. Let A be a 3 cross 3 singular matrix with two of the eigenvalues are given to you. Okay, and it is a singular matrix. What does it mean? It is a singular matrix. Okay, singular matrix whose determinant is 0. Singular matrix whose determinant is 0. Let A be a 3 cross 3 singular matrix and two of the eigenvalues, such a determinant is 0. That means product of eigenvalues is also 0. So one of the eigenvalue has to be compulsorily 0. Okay, now A be a 3 cross 3 matrix. Okay, so what are the lambdas corresponding to A? 2 and 3 and this is missing, so this has to be 0. Okay, this has to be 0. Okay, so I can now say that what are the eigenvalues of A is 2, 3 and 0. Okay, so what is the eigenvalue? So sequence mein likh lete, that is simply 0, 2 and 3. Okay, now I want the number of linearly independent eigenvectors. I'll tell you the property. Okay, but of what? I want it for A cube plus 2A plus I. Okay, can you find out the eigenvalues? Although this is on eigenvectors, but can you write down all the eigenvalues? So again, which property? A power n property. Whatever operation you apply to A, same applies to the eigenvalue. The first is A cube, that is all three I will write. First is 0 cube, 2 into 0 plus I, so I की जगह 1 लिखेंगे. Next one will be same operation applied to lambda equal to 2, so that is 2 cube plus 2 into 2 plus 1. And third one is going to be, that is the 3 cube plus 2 into 3 plus 1. Okay, so this is 1. Okay, 8 plus 4 plus 1, that is 13. Okay, and 27 plus 6 plus 1, that is 34. Okay, just check out the calculation once. 1, 13 and 34. 1, 13 and 34. Now see how many of them are distinct. How many of them are distinct? Okay, there are 3 distinct eigenvalues. Okay, there are 3 distinct eigenvalues. Okay, there are 3 distinct eigenvalues. Okay, look into the property. The number of linearly independent eigenvectors. The number of linearly independent eigenvectors is equal to the number of distinct eigenvalues. Number of distinct eigenvalues. Here all 3 are distinct. Okay, here all 3 are distinct. So I can say that the matrix will have 3 linearly independent eigenvectors. 3 linearly independent eigenvectors. Answer is going to be 3. Answer is going to be 3. Acha, with this there is one more concept to be related. So let's talk about that. Okay, there's one more concept to be related. Uski baat kar lete hain. Okay, look into this. Look into this question here. given a matrix Q, some matrix is given to you, and P is equal to V1, V2, V3 is the matrix formed by linearly independent eigenvectors. Okay, अब ये concept clearly बोल रहा है P equal to V1, V2, V3 is the matrix formed by linearly independent eigenvectors. Okay, it is formed by linearly independent eigenvectors. So how many independent eigenvectors are here? How many independent eigenvectors are here? Clearly bola hai, this matrix is formed by linearly independent eigenvectors. So that means V1, V2, V3, all three linearly independent. Okay, so you have three. Yeah, in general, let me tell you, a matrix is said to be diagonalizable. Okay, a matrix can be diagonalizable if it has n. अगर n cross n मान लूं मैं, let me call it as n cross n. So if it has n linearly independent eigenvectors, if it has n linearly independent eigenvectors, then it is said to be diagonalizable. Yeah, I can also say if it has n distinct eigenvalues, linked to the previous property, if it has n distinct eigenvalues. Okay, so they are not trying to calculate eigenvalue, but I'm sure, you know, if the data is totally correct, so it should have the three eigenvalues, three distinct eigenvalues. Three to hoga hi, but three distinct eigenvalues. Okay, now if a matrix is diagonalizable, okay, what is that diagonal matrix? Okay, what is this P? Written hai na, P inverse QP is written as the matrix lambda. Okay, Q is the actual matrix. Okay, and P is the matrix containing the eigenvectors. Oh my god, I just need to put the charger, guys. Just a minute. Yeah, now it is okay. So what I'm telling you is, okay, we write down, in that case, if the matrix is diagonalizable, we write down P inverse QP is equal to lambda. What is the P? P is simply the matrix containing the eigenvectors. Okay, P is simply the matrix that is going to contain all the three eigenvectors, and hence it is going to be 3 cross 3. Okay, because every eigenvector is a column containing 3 elements. Okay, so eventually 3 columns, but all the columns have 3 elements, so 3 rows will be there. It is a 3 cross 3 matrix. What is this matrix? Okay, the diagonal eigenvalue matrix. Okay, this is given by a 3 cross 3 matrix, 3 cross 3 diagonal matrix, such that all the diagonal elements are respectively equal to the diagonal, are respectively equal to the eigenvalues. Okay? Yes, Ankit, correct. Okay, so if a matrix is diagonalizable, and what is the condition for that? इस पे factual question भी आ सकता है. Okay, a matrix is diagonalizable, that means it should have n linearly independent eigenvectors, or it should have n distinct eigenvalues. Then I can write down the matrix Q. This is the matrix of concern Q, as P inverse QP equal to lambda, where P is the matrix containing the eigenvectors and lambda is the diagonal matrix containing all the eigenvalues. Okay, so here what are the eigenvalues, and they are asking what is the sum of the absolute values of the elements of the matrix P inverse QP. Okay, so here what is the P inverse QP? Here what is the P inverse QP? Okay, that is equal to, acha, if they only ask the sum of the elements, okay, if they ask the sum of the elements of this matrix, ध्यान रखना, if they only ask the sum of the elements of the matrix, okay, P inverse QP, okay, that is equal to lambda, and sum of the elements is lambda 1 plus lambda 2 plus lambda 3, and that should be the trace of the original matrix, so answer should be 6. But here they are asking the sum of the absolute values. Okay, modulus lambda 1, modulus lambda 2, modulus lambda 3. तो actually eigenvalues calculate करना पड़ेगा इस question के लिए. Okay, actually eigenvalues will be calculated here. So that again goes to lambda cube minus beta 1 lambda square. Beta 1 is the trace. Okay, यहीं पे लिख देते हैं what is beta 1, beta 2, beta 3. Okay, the beta 1 is okay trace. That is equal to 6. What is the beta 2? Okay, so first आ जाएगा 0 minus 4. Next it is going to be with respect to 0, 9 minus 16. Correct. Next, the last one, it is going to be 0 minus 4. Okay, so this is total equal to minus 8 minus 7. So minus 15 it is. And what is the value of beta 3? That is going to be the determinant. And what should be the determinant for this matrix? Okay, if I let's solve regularly only. First of solve here, so I have, where is that question? Sorry. Okay, 3 into 0 minus 4 minus of 2, 6 minus 8, that is minus 2, and plus, okay, 4, and that is 4. So determinant kitna aa gaya? That is minus of 12 plus of 4 plus 16. Okay, so that should be 8. Just check the numbers, okay? Just check the numbers. Okay. Okay. Yes. So what is the characteristic equation? Lambda cube minus beta 1 lambda square, okay, plus beta 2 lambda minus beta 3 equal to 0. So what are the eigenvalues? Okay, let me tell you the eigenvalues here, because we need to solve this, okay, equation. So I'll tell you these eigenvalues here directly, okay, so that we focus on the concept of this question. And the last one element is minus 8. Formed by linearly independent eigenvectors. नहीं, something is fishy here. ये हो गया 6. Then check the calculations guys. 0 minus 4, then you have 9 minus 16, perfect. And then finally you have 0 minus 4, minus 8 and minus 7. Beta 3 is equal to 3, then minus 4, minus 2 into 6 minus 8, that is minus 2, perfect. And 4 into 2 to the 4. So minus 12 plus 4 plus 16. Okay, that is 20 minus 12, 8. ये भी minus 50 lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 and plus 15 into n. नहीं, lambda cube minus beta 1 lambda square plus beta 2 lambda. This is correct, Ankit. Plus beta 2 lambda. That part is correct. कुछ तो numbers में error है. There is something not correct with the numbers. There is something which may. Let me check the source file actually. Let me check up the source file. Just give me a minute. Just give me a minute. Oh, so यहाँ पे the data is not correct. The data is not correct. Okay, the data is not correct because the eigen values जो मेरे पास भी आ रहा है, एक बार फिर से check करते हैं. I am getting it as 8 minus 1 minus 1. I mean, I've just checked the question. I've just checked the question. The data is okay, but the answer that is coming is 8 minus 1 minus 1. Okay, it is not distinct. This one is not distinct, and hence it can have only two independent eigenvectors, whereas the question says it is formed by linearly independent eigenvectors. Clearly, these three are not linearly independent. If two distinct eigenvalues, it will have two independent eigenvectors. So something is not correct here. Something is not correct here. Okay. So guys, what is the answer? अभी आपको let's forget this data. Okay, let us forget this data क्योंकि ये not distinct आ गया है. Okay. Okay. Not distinct आ गया है. But what is the answer? What is the sum of the eigenvalues? What is the sum of the absolute values of the elements of this matrix? Okay. So the elements of the matrix P inverse QP are lambda 1, lambda 2, lambda 3. Rest all are 0. So your answer should be actually sum of the absolute value. That is modulus of lambda 1 plus modulus of lambda 2 plus modulus of lambda 3. Yeah, what I'll do is I'll just change the question. Question को थोड़ा सा change कर देते हैं. If you want to match the option, ना, just change this question slightly. Okay. Let us calculate the sum of the values. Let us just calculate sum of the values. Okay, let's not focus on the absolute values here. Sum of the values. Okay. Data is something wrong here. Okay, data is something wrong. Okay, the sum of the values, if I take, so that is lambda 1 plus lambda 2 plus lambda 3. Sum of the values of all the elements, that is lambda 1 plus lambda 2 plus lambda 3, that is directly equal to the trace also. That is directly equal to trace also, and it should be 6. Okay, so modifying the question and making the answer as option number D. A slight modification in that. Okay, rather than changing the question and changing the data here. Clear, everybody? Hope you have got this concept. Right? Now, chalo, your time is almost approaching 1. So that is why I'm not changing this question. One more variety let us discuss here. Okay, one more variety. Let's come up here. Okay, any confusion, please ask me. Okay, we have just modified the previous question slightly. Okay, if a is equal to 3, 1, 1 minus 3, what is a power n? What I should apply to solve this question? Can you tell me? What should be applied to solve the question? Time is also approaching 1 p.m. But almost whatever I wanted to cover, it's covered. Just one more case is there, so usko bhi cover kar lete. Let's not leave anything, because even at the end of 2 hours, I'm finding that attendance is also now disturbed. Students get tired easily, much more easily than I am. Yes, it is Kylie Hamilton. Okay, to find out the higher powers. Okay, whenever the question takes you to higher power, don't think that you will calculate a power 9 by repeatedly multiplying. No, you will go to the Kylie Hamilton theorem, which simply says that every square matrix will satisfy its own characteristic equation. Every square matrix satisfy its own characteristic equation. So what is the characteristic equation here? Right, 2 cross 2 hai na, so characteristic equation, as I have already told you directly, lambda square minus trace into lambda plus determinant. So what is the determinant? Minus 9 minus 1. So I have lambda square, this part is 0, minus 10 equal to 0, correct? Okay, apply the Kylie Hamilton. This is only the characteristic equation, and according to Kylie Hamilton, every square matrix will satisfy this equation. This equation is in lambda, so matrix A will satisfy this equation. So A square, if you replace A here, it will satisfy. But the only problem is you can't write down A square minus 10, because A square will be a matrix and 10 is a number. Okay, and matrix minus scalar number not possible. So you multiply 10 by identity matrix. Okay, so that you have matrix and matrix terms only. Okay, so A square minus 10i is 0. So first of all, you get the A square, which is equal to the 10i, and then what is the A ki power 9? Okay, A ki power 9 there can be broken as A square power 4, that will be A power 8 into another A. Dekho na, A square ki power 4, A ki power 8, and then A, so total A ki power 9. Okay, what is A square? 10i ki power 4 into A, and what is 10 power 4? 10,000, so answer is 10,000 A. Answer is known as the 10,000 A. Answer is the 10,000 A, option number A. Okay, very simply by Kylie Hamilton. Don't even think you have to form A power n by repeated multiplication. That is very calculative and inappropriate method, because that's going to take our time. That's going to take and kill up your time. Okay, have a look into this next question. Suppose that the 2 cross 2 matrix A, okay, has the eigenvalues 4 and minus 2. Okay, for each integer n greater than equal to 1, there are 4 real numbers B and Cn, there are real numbers B and Cn which satisfy the relation A power n equal to B power n an plus C power n identity. Okay, A power n, again power, higher power is coming. Okay, that can be any higher power n greater than equal to 1. Okay, then what is the value of B3 plus C3? B3 plus C3, matlab you have to put n equal to 3. B3 C3 kab aayega? When you put n equal to 3. When you put n equal to 3, and if you put n equal to 3, you will have the relation A cube here. Okay, A cube here, that will be B3 A cube plus C3 identity. Clear? C3 identity. So what is A cube? We have to think in that direction. Okay, we have to think in that direction. A cube is equal to B3 A cube plus C3i. What is the value of A cube? Okay, so agar hum matrix A की बात करें, so eigen values are 4 and minus 2. Okay, 4 and minus 2. So what is the characteristic equation for this matrix? Eigenvalue are the roots of characteristic equation, and before I apply Cayley-Hamilton, I need the characteristic equation. So lambda minus 4 and lambda plus 2 should be 0. Okay, then only 4 and minus 2 are the roots. No? So I am given the factorized form, and now I multiply, I get lambda square minus 4 and plus 2. So minus 2 lambda minus 8 equal to 0. Minus 4 into 2. Correct? Yes. So what is my characteristic equation, dear? It is lambda square minus 2 lambda minus 8 equal to 0. So if I apply the Cayley-Hamilton theorem, every square matrix will satisfy its own equation. So it will satisfy lambda equal to a, so a square minus 2a minus 8i equal to 0. Okay, the value of a square is equal to 2a plus 8i. It is equal to the 2a plus 8i. That is a square. So what will be a cube then? How to approach a cube? Okay, simply a square into a. So that is 2a plus 8i again multiplied by a. Okay, so what is a cube? It is turning out to be 2a square, okay, plus 8a. Okay, further what is a square? Further, what is the value of a square? We can replace it, na? We can replace it once again, no issues. What is the a square? 2a square. A square is 2a plus 8i. Okay, and then further plus 8a. So I am able to feel that a cube is equal to 2 2s are 4a. 4a plus 8a, total 12a. Okay, and then plus 16i. Are they trying to say that a power n is b power n a plus c and I? It should be b and a. I think it should be b and a. Then I have the 12 plus 16 answer as 28. It is only b and a. Okay, it should be b and a. Well, let me check the source question. Okay. Yeah, इससे भी आ रहा है क्या? We can check up. We can substitute a cube on both the sides and maybe try to do some more calculations around this. Okay, we can try to do some calculation. Maybe the question is correct. Let's not check it. So it is bn a cube plus cn, b3 a cube plus c3. Okay. So as you are telling इससे आ रहा है, तो let me check. Let me put a cube. That is 12a plus 16i should be equal to b3 12a plus 16i. Okay. Plus c3i. Let us see if this is working out. So 12a plus 16i is equal to 12 b3a plus 16 b3i plus c3i. Okay, shift the a terms on one side. Okay, shift the a terms on one side. Agar if I compare both the sides, 12, if I compare the a to a terms, so 12 is equal to 12 b3, b3 is equal to 1. Right, and then coefficient of I, so 16 is equal to 16 b3, sorry that was c kahan chala, 16 b3 plus c3, so 16 is equal to 16 plus c3, b3 का value तो 1 ही हो गया, नहीं, c3 is 0, okay, c3 is 0, right, c3 is 0, right, and then in that case 1, and c3 cannot be 0, otherwise the question becomes illogical, na? So ये question में typo error है. Sorry guys, I think 2 or 3 typo errors have happened today. Okay, if you take this as 0 and if you take b as 1, so a power n is always a power n. That is just an illogical question. That is not illogical statement, but the question is illogical. A3 is A3. Okay, what else we need to solve? What else we need to put the effort? No. Okay, so please take it as only a. Okay, इसको only a ले लेते हैं हम, ठीक है? Okay, so a cube should be b3a plus c3i. That should be the correct question. Okay, then it makes complete sense. Then it makes the complete sense, right? Okay, so what is the question? Let's write down the question once again, and the question is a cube is equal to b3a plus c3i. But what is the a cube we have solved? 12a plus 16i is b3a plus c3i. So hence b3 is 12, c3 is equal to 16. The sum of them is 28. The sum of them is 28. Very correct answer is B. ठीक है जी? Very correct answer is B. Very correct answer is B. How by eigenvalues, Ankit? Can you please specify? If you tell me in detail, I'll tell you whether it is the right or wrong. The correct answer is B. Okay. Also, I'll just check up the question in the source files also. But let me also tell you. Let me also tell you the password for today's PDF. Okay, today's PDF will be shared in the Telegram group and having the password CHT, that is the Cayley-Hamilton theorem. In short, only CHT. In short, that is only CHT. No. A cannot be a number, na? No. Cayley-Hamilton theorem is applicable on characteristic equation, right? Not on a value. A cannot be taking a value, na? So no, wrong. That's the wrong approach. In any of the question, that is not valid. Okay. So this is Cayley-Hamilton theorem, that is CHT is going to be the password for today's PDF. Okay, so A power n is Bn A plus I, and I'll check this question later on from the source file also, but I'm sure कि यही होना चाहिए question. ठीक है जी? All capitals, all capitals. It is all capitals. ठीक है जी? So yeah, time has approached. Okay, 2 p.m. But I think we have learned a lot today. We have learned, everything that we needed to learn with respect to characteristic equation not given. So we have calculated characteristic equation. We have the way for that. Don't worry. Okay, ji. So chaliye, I'll just at the end share you the Telegram. Okay, where you will get the PDF. You can join this. So guys, that's it from my side. Okay, bye bye. Thank you. Stay safe and do take care of yourself. See you in another session. And if you have liked it, okay, if you have liked the today's effort of complete eigenvalue, eigenvector, do not forget to hit the like button, put your attendance, and do mention in the comment box if this session really helps you, what other topics from maths, so that Sundays we'll utilize and plan up some important like eigenvalue, eigenvector. I believe, okay, variety of questions done today. Okay, it's a perfect, good revision. Similarly, any other topics you need from maths, okay, through which we can revise with all these multiple questions, do mention in the comment box. I'll take up the students' opinion, because what you need, I'll plan accordingly, and I'll plan the upcoming Sundays. Bye bye. Thank you. Stay safe and take care of yourself.